The two ropes seen are used to lower a 255 kilogram piano exactly 9 meters from a second-story window to the ground. How much work is done by the weight force vector, how much work is done by the T1 force vector, and how much work is done by T2 force vector. Okay, so let's make a list just to get everything straight. So that we say the distance that we're moving it is 9 meters. Then what else do we need? I'm going to put an arrow here to say that the direction is going down. Now this might seem a little kind of redundant right now. I find it's helpful, and we'll talk about why in just a minute. Okay, so we want to know how much work is done by all of these. So what is the formula for work? Work, or W, is equal to a force times the distance and cosine of the angle. How do we get the angle though? Because they give us a couple here, and the trap a lot of students fall into is they just take whatever angle is given and they just assume that it's the right angle, but that's not always the case. Sometimes they're trying to trip you up. So the angle that we're going to use is the angle between the force vector and the direction. So in this case, if we write it, the direction is down, and now we have weight going down, we have T1, or T2 I mean, and T1 up here. So the angle that we're going to use is, I guess if we put a little x-axis over the top of this, they say this is 60, and they tell us that this is 45, and then of course these are going to be 90-degree angles right there. So the angle that we're going to use for T1 is going to be 60 plus 90, so that angle is actually going to be 150. Now what angle are we going to use for this one? It's 45 plus 90, so we're going to use cosine of 135. So the reason we do this is kind of like when we were talking about torque. All we care about is the part of the force that is making it go around in a circle. We don't care about the force that's pushing it directly into the center of the circle. So in this case, if we continue this and have a y-axis on the top, all we care about is we have an x component and we have a y component. All we care about is a y component. This x component right here is not helping us lift that piano up and down. Like, yeah, sure, you can argue it's going side to side or whatever, but as far as lowering it to 9 meters, it is not helping out at all. And all we want is just this y component. So you could also argue that, hey, well, this is 45, so this is also 45. Why can't I just use cosine of 45? And it would give you the same answer, except it would be positive. But in this case, since the direction is going down, both of our tension in the rope is in the negative direction, so we'll get a negative work. And so if you plug in the calculator cosine of 135 and cosine of 45, you'll get the same answer, except that you'll find that cosine of 135 will give you a negative value. So if you do the cosine of the angle between the force vector and the direction arrow, then that will always give you the correct value, positive or negative. Okay, so now that we've talked about all that, let's just plug everything in. So we know, let's do T1 first. So T1 is equal to the force times the distance times the cosine of theta. So the force, they tell us, is 1830 newtons. It's equal to 1830 newtons. The distance that we go is, of course, 9 meters. And the cosine of the angle that we just talked about is 150. So when we do all that, that gives us a negative 14,263.44. And then what are the units for work? That is joules. Whoops, work. I said T1, I guess That's not wrong. Okay, so work is equal to joules, or energy. So we have negative 14,263.44 joules. And then if they make you put that into kilojoules, that would be negative 14 kilojoules. I don't remember if they make you put it in kilo or not, so I'll just leave the rest of them in just plain joules and you can convert them. Okay, so now let's do T2. So the work for T2 is equal to the force of T2 times the distance times the cosine of that angle. So the force for T2 is 1295 newtons. So work is equal to 1295 newtons times the distance, of course 9 meters, and the cosine of that angle is 135. Times cosine of 135, and that gives you negative 8,240 joules. Okay, so now let's do the work for the weight vector. So work is equal to FD cosine of the angle. So in this case, if we go back to our picture real quick to talk about the angle, the distance, direction, and the work are going in the same direction, so we'll get a cosine of 0, and when you plug that in, that will give you 1. So work is equal to, what was it, 2,500 newtons times 9 meters times the cosine of 0, which is 1. So we get 22,500 joules. And that, I believe, is everything.